Question 1. System analysis indicates that a critical Oracle database is experiencing significant performance degradation during peak operational hours, impacting user productivity. The database administrator needs to identify and implement a solution to improve query response times without compromising data integrity or violating Oracle's support policies. The administrator has access to Oracle Enterprise Manager and the database's diagnostic pack. Which of the following approaches best aligns with professional best practices and the regulatory framework for Oracle-based database services 2023 professional? Option A. Utilize the Automatic Workload Repository (AWR) and Automatic Database Diagnostic Monitor (ADAM) to identify performance bottlenecks and then apply recommendations from the SQL Tuning Advisor or adjust relevant database parameters based on ADAM findings. Option B. Manually modify internal Oracle Data Dictionary views that are suspected of causing performance issues based on forum discussions and anecdotal evidence. Option C. Disable diagnostic features like AWR and ADAM to reduce system overhead, assuming that the current performance issues are transient and will resolve themselves. Option D. Implement a third-party performance tuning tool that claims to offer significant improvements without cross-referencing its methodologies with Oracle's official documentation or support recommendations. The correct answer is A. Utilize the Automatic Workload Repository (AWR) and Automatic Database Diagnostic Monitor (ADAM) to identify performance bottlenecks and then apply recommendations from the SQL Tuning Advisor or adjust relevant database parameters based on ADAM findings. Explanation. The scenario presents a common challenge in database administration, balancing performance optimization with data integrity and security, especially when dealing with sensitive information. The professional must make a decision that impacts system availability, data accessibility, and compliance with Oracle's licensing and support policies. The core challenge lies in selecting a method that is both effective for performance tuning and adheres to the strict guidelines of the Oracle-based Database Services 2023 Professional Certification, which implicitly covers best practices and supported configurations. The correct approach represents best professional practice because it leverages Oracle's documented and supported methods for performance tuning, such as using Automatic Workload Repository (AWR) and Automatic Database Diagnostic Monitor (ADAM) for analysis, and then applying appropriate SQL tuning advisors or parameter adjustments. This aligns with the principles of maintaining a stable, supported, and efficient database environment as expected by Oracle and its customers. It prioritizes data integrity and avoids unsupported modifications that could lead to unpredictable behavior or void support agreements. An incorrect approach involving manual, undocumented modifications to internal Oracle data dictionary views or system parameters without explicit Oracle support guidance would be a significant regulatory and ethical failure. This could lead to data corruption, system instability, and a violation of Oracle's support policies, potentially incurring additional costs or rendering the database unsupported. Another incorrect approach, such as disabling essential diagnostic features to reduce overhead, would be ethically questionable, as it hinders the ability to diagnose future performance issues and maintain system health, potentially impacting service-level agreements and user trust. Relying solely on anecdotal evidence or third-party tools without validating against Oracle's recommended practices would also be a failure, as it bypasses established, tested methodologies and could introduce unforeseen risks. Professionals should employ a structured decision-making framework. This involves 1. Clearly defining the problem and its impact. 2. Identifying all potential solutions, considering both supported and unsupported methods. 3. Evaluating each solution against established criteria: effectiveness, risk, cost, compliance, and supportability. 4. Consulting official Oracle documentation and support resources for guidance on best practices and supported features. 5. Prioritizing solutions that are documented, tested, and supported by Oracle. 6. Implementing the chosen solution with thorough testing and monitoring. 7. Documenting the process and outcomes for future reference and auditing. Question 2. Operational review demonstrates a significant degradation in query response times for a critical application database. The database administrator suspects a suboptimal configuration parameter related to memory management might be contributing to the issue. What is the most professional and risk-averse approach to address this potential performance bottleneck? Option A. Conduct a thorough root cause analysis using Oracle diagnostic tools to pinpoint the exact cause of the performance degradation, test potential solutions in a development environment, and implement the validated fix during a scheduled maintenance window. Option B. Immediately modify the suspected memory management parameter in the production database to a commonly recommended value for improved performance and monitor the system. Option C. Advise the application development team to optimize their SQL queries, as performance issues are typically application-related, and defer any database-level investigation. Option D. Apply a generic performance tuning script that includes adjustments to various configuration parameters, including memory management, to the production database. The correct answer is B. Immediately modify the suspected memory management parameter in the production database to a commonly recommended value for improved performance and monitor the system. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and security, particularly in a production environment. The professional must make a judgment call on the best course of action when a performance issue is identified, considering the potential impact on business operations, data availability, and compliance with Oracle's recommended practices, and the specific regulatory framework governing the exam's jurisdiction, which, for 1Z0-1093-23, implies adherence to Oracle's own best practices and general IT governance principles, without specific external regulatory bodies being mandated for this exam's scope unless explicitly stated. The challenge lies in selecting an approach that is both effective in resolving the performance bottleneck and minimizes risk. Correct approach analysis. The correct approach involves a systematic, controlled, and well-documented process. This aligns with Oracle's best practices for database maintenance and troubleshooting, emphasizing minimal disruption and maximum data safety. By first identifying the root cause of the performance issue through diagnostic tools, and then planning and testing the solution in a non-production environment, the administrator ensures that the fix is effective and does not introduce new problems. Implementing the change during a scheduled maintenance window further minimizes business impact. This methodical approach is considered best professional practice because it prioritizes data integrity, system stability, and business continuity, all critical aspects of database service management. It also aligns with the principle of least privilege and controlled change management, which are fundamental to robust IT operations. Incorrect approaches analysis. Implementing a performance tuning parameter change directly in the production environment without prior analysis or testing is a significant regulatory and ethical failure. It violates the principle of controlled change management, which is a cornerstone of IT governance and essential for maintaining system reliability and data integrity. Such an action could lead to unintended consequences, such as data corruption, system downtime, or security vulnerabilities, all of which could have severe operational and reputational repercussions. Applying a generic performance fix without understanding the specific root cause is also professionally unacceptable. This approach demonstrates a lack of diagnostic skill and a disregard for the unique characteristics of the database environment. It risks exacerbating the problem or creating new ones, potentially impacting data availability and compliance with service-level agreements. This is an ethical failure as it represents a failure to exercise due diligence and professional competence. Ignoring the performance issue entirely until it significantly impacts users is a dereliction of duty. Database administrators are responsible for proactive monitoring and maintenance. Failing to address performance degradation in a timely manner can lead to data loss, extended downtime, and a breach of service-level agreements, which are often implicitly or explicitly governed by operational standards and customer expectations. This constitutes a failure to uphold professional responsibilities. Professional reasoning. Professionals should approach performance issues with a structured methodology. This involves 1. Accurate identification and diagnosis of the problem using appropriate Oracle diagnostic tools. 2. Thorough research and understanding of potential solutions, considering their impact on the specific database environment. 3. Rigorous testing of proposed solutions in a non-production environment that closely mirrors production. 4. Careful planning of the implementation, including rollback procedures and communication strategies. 5. Execution of the change during a scheduled maintenance window, with appropriate monitoring. 6. Post-implementation verification and documentation. This systematic process ensures that decisions are data-driven, risks are mitigated, and the integrity and availability of the database are maintained. Question 3. Governance review demonstrates that the development and testing environments for a critical Oracle database application are currently using direct copies of production data, posing a significant risk of sensitive information exposure and potential noncompliance with data privacy regulations. As the Oracle Database Administrator, what is the most appropriate action to mitigate this risk while ensuring the usability of data for development and testing purposes? Option A. Restrict access to the development and testing environments to only a few senior personnel. Option B. Replace all production data in development and testing with entirely synthetic, randomly generated data. Option C. Implement Oracle's data masking and obfuscation features to create realistic, anonymized datasets for development and testing environments. Option D. Continue using production data copies but enhance security controls around the development and testing environments. The correct answer is C. Implement Oracle's data masking and obfuscation features to create realistic, anonymized datasets for development and testing environments. Explanation. This scenario is professionally challenging because it requires balancing the immediate need for data accessibility with long-term data security and compliance obligations. The Oracle Database Administrator, DBA, must navigate the complexities of data masking and obfuscation techniques while ensuring that the data used for development and testing remains representative enough to be useful, without exposing sensitive information. The core challenge lies in implementing a solution that satisfies the business's need for realistic test data, while adhering to the strict data privacy regulations mandated by the Oracle Database Services 2023 Professional Exams Jurisdiction, which emphasizes robust data protection and compliance. The correct approach represents best professional practice because it directly addresses the identified governance gap by implementing a comprehensive data masking strategy. This strategy, by definition, aims to protect sensitive data while still allowing for its use in non-production environments. Utilizing Oracle's built-in data masking capabilities, such as data redaction or obfuscation functions, ensures that the implementation is integrated with the database's security features and is auditable. This aligns with the principles of least privilege and data minimization, which are fundamental to regulatory compliance and ethical data handling. By systematically applying masking rules based on data sensitivity and usage context, the DBA ensures that development and testing can proceed with realistic, yet anonymized, data, thereby mitigating the risk of data breaches and noncompliance. An incorrect approach that involves simply copying production data without any modification is professionally unacceptable due to significant regulatory and ethical failures. This directly violates data privacy laws and best practices by exposing sensitive customer or business information in less secure environments. It creates an unacceptable risk of data leakage, unauthorized access, and potential identity theft, leading to severe legal penalties, reputational damage, and loss of customer trust. Another incorrect approach, such as using entirely synthetic data that bears no resemblance to production data, is also professionally problematic. While it protects sensitive information, it fails to meet the business requirement for realistic test data. This can lead to the development and deployment of applications that do not function correctly with actual production data, causing operational issues, increased debugging efforts, and ultimately, a failure to deliver value. This approach neglects the practical needs of the development and testing teams, demonstrating a lack of understanding of the broader business context and the interconnectedness of data security and application functionality. The professional reasoning process for similar situations should involve a thorough risk assessment of data sensitivity, a clear understanding of regulatory requirements, and a collaborative approach with business stakeholders to define acceptable levels of data realism for non-production environments. The DBA should then evaluate and implement appropriate data protection techniques, prioritizing solutions that are integrated, auditable, and maintain data utility. Continuous monitoring and periodic review of the implemented controls are essential to adapt to evolving threats and regulatory landscapes. Question 4. Risk assessment procedures indicate that a critical Oracle database is experiencing a gradual but noticeable decline in query response times, impacting user productivity. The database supports essential business operations. Which of the following approaches is the most appropriate for addressing this performance degradation? Option A. Implement a series of aggressive, untested index rebuilds across all major tables to potentially speed up data retrieval. Option B. Systematically analyze database performance metrics and execution plans using Oracle's diagnostic tools to identify specific areas of concern before implementing targeted tuning strategies. Option C. Defer addressing the performance issue until it becomes critical enough to warrant immediate intervention to avoid unnecessary administrative overhead. Option D. Immediately apply a comprehensive set of database parameter tuning scripts downloaded from an online forum, assuming they will universally improve performance. The correct answer is B. Systematically analyze database performance metrics and execution plans using Oracle's diagnostic tools to identify specific areas of concern before implementing targeted tuning strategies. Explanation: scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with the need for robust data integrity and adherence to operational policies. The professional must not only identify potential performance bottlenecks, but also evaluate solutions within the constraints of established best practices and potential regulatory implications, even if not explicitly stated as a direct compliance issue in the question. The challenge lies in selecting an approach that yields tangible performance gains without introducing unforeseen risks or violating implicit operational guidelines that safeguard data. Correct approach analysis. The correct approach focuses on a systematic, data-driven method for identifying and addressing performance issues. This involves leveraging Oracle's built-in diagnostic tools to pinpoint the root cause of the slowdown. By analyzing execution plans, wait events, and resource utilization, the administrator can make informed decisions about tuning specific SQL statements, optimizing indexing strategies, or adjusting database parameters. This methodical approach ensures that changes are targeted, effective, and have a minimal impact on other database operations. It represents best professional practice because it is proactive, minimizes disruption, and is grounded in objective data, aligning with the principle of responsible system management. Incorrect approaches analysis. Implementing broad, untested parameter changes without prior analysis is a significant regulatory and ethical failure. It violates the principle of due diligence and responsible system management. Such an approach can lead to unintended consequences, including data corruption, system instability, or security vulnerabilities, all of which could have severe operational and potentially legal ramifications if data integrity is compromised. Applying a one-size-fits-all tuning script without understanding the specific workload and environment is equally problematic. This bypasses the critical step of diagnosing the actual problem, leading to inefficient or even detrimental changes. It demonstrates a lack of professional rigor and can result in wasted resources and further performance degradation, failing to meet the professional obligation to provide effective and efficient database services. Ignoring the performance issue altogether, despite evidence of degradation, is a failure to uphold professional responsibilities. It can lead to decreased user productivity, potential data loss due to system unreliability, and ultimately, a breach of service-level agreements. This passive approach can also have indirect regulatory implications if the performance degradation impacts compliance-related reporting or operations. Professional reasoning. Professionals should approach performance optimization by first establishing a baseline of current performance. Then, they should utilize diagnostic tools to identify specific bottlenecks. Solutions should be developed based on this diagnosis, prioritizing changes that address the root cause. Before implementing any changes in a production environment, thorough testing in a non-production environment is crucial. Post-implementation monitoring is essential to validate the effectiveness of the changes and identify any new issues. This iterative, data-driven process ensures that optimizations are effective, safe, and aligned with professional standards of care. Question 5. Benchmark analysis indicates that a critical Oracle-based Database Services 2023 professional upgrade is required to address security vulnerabilities and improve performance. The business has requested the upgrade be completed within a tight deadline to minimize operational disruption. Which approach best balances the need for timely implementation with the imperative of maintaining data integrity and service availability? Option A. Perform the upgrade on all production servers during peak business hours to demonstrate rapid deployment, without extensive pre-testing. Option B. Conduct a full backup and recovery test, followed by a staged rollout to a subset of production servers with a clearly defined rollback plan. Option C. Implement the upgrade on a development environment that has minimal resemblance to production, and then proceed directly to all production servers. Option D. Execute the upgrade directly on all production servers during a scheduled maintenance window, ensuring a backup is taken beforehand. The correct answer is D. Execute the upgrade directly on all production servers during a scheduled maintenance window, ensuring a backup is taken beforehand. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, ensuring data integrity and availability while adhering to strict operational requirements. The professional is tasked with implementing a critical database service upgrade. The challenge lies in balancing the need for minimal downtime, which directly impacts business operations and potentially revenue, with the absolute necessity of maintaining data consistency and preventing data loss. The pressure to meet aggressive timelines, often driven by business stakeholders, can lead to shortcuts that compromise security or reliability. Furthermore, the complexity of modern database environments, with their interdependencies and potential failure points, amplifies the risk associated with any change. Careful judgment is required to select an approach that mitigates these risks effectively without unduly delaying essential system maintenance. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes thorough testing and validation in a non-production environment that closely mirrors the production setup. This includes performing a full backup and recovery test to confirm the integrity of the backup process and the ability to restore the database to a known good state. Subsequently, a staged rollout to a limited set of production servers or a pilot group of users is crucial. This allows for real-world performance monitoring and the identification of any unforeseen issues in a controlled manner. The ability to quickly roll back to the previous stable version, if problems arise, is a non-negotiable aspect of this best practice. This methodical approach ensures that the upgrade process is robust, minimizes the risk of data corruption or extended downtime, and aligns with the principle of least privilege and due diligence in system administration, safeguarding the integrity and availability of the Oracle-based database services. Correct approach is analysis. Implementing the upgrade directly on all production servers without prior testing in a staging environment that accurately reflects production configurations is a significant regulatory and ethical failure. This bypasses essential validation steps, increasing the likelihood of introducing errors that could lead to data loss or extended service outages, directly violating the duty of care to maintain service availability and data integrity. Performing the upgrade during peak business hours without a comprehensive rollback plan is also professionally unacceptable. This demonstrates a disregard for the potential impact on business operations and customer access, which can have severe financial and reputational consequences. The absence of a rollback plan indicates a failure to adequately prepare for contingencies, a core tenet of responsible system administration. Skipping the backup and recovery testing phase, even if a backup is taken, is a critical oversight. The integrity of the backup itself and the ability to successfully restore from it are paramount. Failing to test this process leaves the organization vulnerable to irreversible data loss in the event of an upgrade failure, a clear breach of data protection and business continuity responsibilities. Professional reasoning. Professionals should approach critical database upgrades by first establishing a clear understanding of the business impact of potential downtime and data loss. This involves engaging with stakeholders to define acceptable risk levels and downtime windows. The decision-making process should then follow a structured methodology. 1. Risk assessment. Identify all potential risks associated with the upgrade, including data corruption, performance degradation, and compatibility issues. 2. Planning. Develop a detailed upgrade plan that includes pre-upgrade checks, the upgrade procedure itself, and a robust rollback strategy. 3. Staging and testing. Create a staging environment that precisely mirrors the production environment. Conduct comprehensive testing of the upgrade process, including functional testing, performance testing, and critically backup and recovery testing. 4. Phased rollout. If possible, implement a phased rollout to minimize the impact of any unforeseen issues. 5. Monitoring and validation. Continuously monitor the system's performance and data integrity post-upgrade. 6. Documentation. Thoroughly document all steps taken, test results, and any issues encountered. This systematic approach ensures that decisions are data-driven, risks are proactively managed, and the integrity and availability of the database services are maintained, aligning with professional standards and regulatory expectations. Question 6. Quality control measures reveal that a critical Oracle database experiencing intermittent performance degradation is logging detailed transaction information that includes customer names and account numbers. The database administrator needs to analyze these logs to identify the root cause of the performance issues, but is concerned about potential data privacy violations. Option A. Halt all performance analysis of the transaction logs due to the presence of sensitive data, opting to address performance issues based on general system metrics without detailed transaction-level investigation. Option B. Directly access and analyze the raw transaction logs containing customer names and account numbers, assuming that internal access is inherently secure and does not require further data protection measures. Option C. Implement a data masking solution to anonymize or pseudonymize sensitive customer information within the transaction logs before analysis, ensuring that only non-identifiable data is used for troubleshooting. Option D. Utilize generic, aggregated database performance metrics that do not contain any specific transaction details, even if this means the root cause of the performance degradation cannot be precisely identified. The correct answer is C. Implement a data masking solution to anonymize or pseudonymize sensitive customer information within the transaction logs before analysis, ensuring that only non-identifiable data is used for troubleshooting. Explanation. Scenario analysis. This scenario presents a professional challenge related to data security and compliance within a database environment. The core difficulty lies in balancing the need for efficient troubleshooting and performance analysis with the strict requirements for protecting sensitive customer data. Missteps in handling such data can lead to severe regulatory penalties, reputational damage, and loss of customer trust. The professional must exercise careful judgment to ensure all actions taken are both effective for problem resolution and fully compliant with data protection mandates. Correct approach analysis. The correct approach involves anonymizing or masking sensitive data before it is used for troubleshooting or analysis. This aligns with the principles of data minimization and purpose limitation, which are fundamental to data protection regulations. By removing or obscuring personally identifiable information, PI, the database administrator ensures that the data used for diagnostic purposes does not expose individuals to risk. This practice upholds the confidentiality and integrity of customer data, demonstrating a commitment to responsible data handling and compliance with relevant data privacy laws. It allows for effective problem solving without compromising regulatory obligations. Incorrect approaches analysis. One incorrect approach involves directly using raw, unmasked customer data for performance analysis. This is a direct violation of data privacy regulations, as it exposes sensitive PII unnecessarily. Such an action could lead to unauthorized access, data breaches, and significant legal repercussions, including fines and sanctions. Another incorrect approach is to completely ignore performance anomalies because of data sensitivity concerns, leading to potential service degradation and customer dissatisfaction. This fails to meet the professional obligation to maintain system performance and availability. A third incorrect approach is to rely solely on generic, nonspecific log data that lacks the detail needed for effective root cause analysis, thereby prolonging troubleshooting and potentially impacting business operations. This approach prioritizes perceived security over actual problem resolution, creating a different kind of operational risk. Professional reasoning. Professionals should adopt a risk-based approach to data handling. When faced with a situation requiring access to potentially sensitive data for operational purposes, the first step is to identify the specific data elements that are truly necessary for the task. Subsequently, implement robust data masking or anonymization techniques to remove or obscure PII. If anonymization is not feasible for a particular diagnostic task, then strict access controls and secure environments should be employed. With clear audit trails, always prioritize compliance with applicable data protection laws and internal security policies. If in doubt, consult with legal or compliance teams. Question 7. Process analysis reveals that a recent internal audit of the Oracle database environment has identified several user accounts with broad administrative privileges that have not been actively used for over 6 months. These accounts were initially provisioned during a legacy project and have not undergone a formal review since. The audit also flagged that some active user accounts have been granted extensive select, insert, update, and delete privileges on sensitive customer data tables, exceeding what is required for their day-to-day operational tasks. The database administrators are concerned about potential security vulnerabilities and compliance risks associated with these excessive permissions. Which of the following actions represents the most appropriate and professionally responsible approach to address these findings? Option A. Disable all user accounts that have not been active for over 6 months and instruct application owners to re-request access for their users if needed. Option B. Rely on the existing audit logs to monitor for any suspicious activity related to these accounts and continue with the current privilege assignments. Option C. Delegate the task of reviewing and adjusting privileges for their respective applications to individual application owners without further centralized oversight. Option D. Immediately revoke all identified broad administrative privileges and re-evaluate active user accounts for necessary access, implementing the principle of least privilege. The correct answer is D. Immediately revoke all identified broad administrative privileges and re-evaluate active user accounts for necessary access, implementing the principle of least privilege. Explanation. Scenario analysis. This scenario presents a professional challenge in managing database security and compliance within the Oracle-based Database Services 2023 professional context, specifically concerning data privacy and access control. The core difficulty lies in balancing the need for efficient data access for legitimate business operations with the imperative to protect sensitive customer information from unauthorized disclosure, as mandated by data protection regulations. The pressure to deliver timely reports, coupled with the potential for human error in granting access, creates a complex environment where adherence to strict security protocols is paramount. The professional must exercise careful judgment to ensure that all access grants are justified, documented, and adhere to the principle of least privilege, thereby mitigating risks of data breaches and regulatory noncompliance. Correct approach analysis. The correct approach involves a systematic review and revocation of all database user accounts that have been granted excessive privileges beyond their immediate job requirements, followed by a regranting of access based on the principle of least privilege. This aligns directly with best professional practices for database security and data governance. Specifically, it adheres to the Oracle Security Framework and general data protection principles that emphasize minimizing the attack surface and preventing unauthorized data access. By ensuring each user has only the necessary permissions to perform their duties, the risk of accidental or malicious data exposure is significantly reduced. This proactive measure also supports auditability, as it establishes a clear and justifiable record of who has access to what data and why. This approach is professionally sound because it directly addresses potential vulnerabilities and proactively enforces security policies, thereby safeguarding sensitive information and maintaining regulatory compliance. Incorrect approaches analysis. One incorrect approach involves immediately disabling all user accounts that have been identified as having broad privileges, without a proper assessment of their business necessity. This is professionally unacceptable because it can disrupt critical business operations, leading to significant productivity losses and potential financial repercussions. Ethically, it fails to consider the impact on legitimate users and their ability to perform their roles. It also bypasses the due diligence required to understand the context of the granted privileges, potentially leading to overcorrection and operational paralysis. Another incorrect approach is to rely solely on the existing audit logs to identify potential misuse without actively reviewing and adjusting privilege levels. This is professionally inadequate as it is a reactive rather than a proactive security measure. While audit logs are crucial for detecting breaches after they occur, they do not prevent them. The ethical failure here is in not taking preventative action to secure data when a known vulnerability, excessive privileges, exists. This approach leaves the organization exposed to ongoing risks. A third incorrect approach is to delegate the privilege review and adjustment process entirely to individual application owners, without centralized oversight or standardized procedures. This is professionally unsound, as it can lead to inconsistent security policies across different applications and databases, creating security gaps and making comprehensive compliance difficult to ascertain. The ethical concern is the abdication of responsibility for data security at a foundational level, potentially leading to a fragmented and weakened security posture across the organization. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes risk assessment and adherence to established security policies and regulatory requirements. This involves 1. Understanding the data sensitivity and regulatory landscape. 2. Conducting a thorough audit of existing user privileges against job roles and responsibilities. 3. Implementing the principle of least privilege through role-based access control and granular permission management. 4. Establishing a robust change management process for all privilege modifications. 5. Regularly reviewing and auditing access controls. 6. Ensuring comprehensive documentation of all access grants and justifications. This systematic approach ensures that security measures are effective, compliant, and minimally disruptive to legitimate business functions. Question 8. The assessment process reveals that a critical Oracle database upgrade is scheduled, and while vendor documentation highlights performance enhancements, there is a lack of clarity on its specific impact on existing application integrations and data archival processes. Which of the following approaches best mitigates potential risks and ensures continued service availability? Option A. Proceed with the upgrade as planned, relying on the vendor's assurances and planning to address any issues that arise reactively after the upgrade is completed. Option B. Perform a superficial review of the upgrade's technical specifications, focusing only on database-level performance metrics, and assume that application and archival processes will adapt without significant issues. Option C. Defer the detailed impact assessment until after the upgrade is deployed, focusing immediate efforts on preparing rollback procedures in case of critical failures. Option D. Conduct a comprehensive impact assessment that meticulously documents all dependencies, potential failure points, and the severity of consequences for database performance, application integrations, and data archival processes, involving key stakeholders in the review and validation of findings. The correct answer is D. Conduct a comprehensive impact assessment that meticulously documents all dependencies, potential failure points, and the severity of consequences for database performance, application integrations, and data archival processes, involving key stakeholders in the review and validation of findings. Explanation. The assessment process reveals a critical juncture in managing Oracle database services, specifically concerning the impact of a proposed system upgrade on data integrity and availability. This scenario is professionally challenging because it requires a proactive and thorough evaluation of potential risks before implementation, balancing the benefits of the upgrade against the potential for disruption. Failure to conduct a comprehensive impact assessment can lead to significant data loss, extended downtime, and noncompliance with service-level agreements, SLAs, all of which have severe financial and reputational consequences. The correct approach involves a systematic and detailed impact assessment that identifies all affected components, potential failure points, and the severity of consequences. This includes evaluating the upgrade's effect on database performance, security, data consistency, and application compatibility. It necessitates collaboration with stakeholders, including application owners, security teams, and business users, to gather comprehensive requirements and understand critical dependencies. This approach aligns with best practices for IT service management, emphasizing risk mitigation and ensuring business continuity, which are implicitly expected under general IT governance frameworks that underpin Oracle database operations. An incorrect approach would be to proceed with the upgrade based solely on vendor documentation, without independent verification of its impact on the specific production environment. This overlooks the unique configurations, customizations, and interdependencies present in any live system, leading to unforeseen issues. Such a failure to perform due diligence can result in breaches of SLAs, potentially leading to contractual penalties and loss of client trust. Another incorrect approach is to defer the impact assessment to the post-implementation phase, treating any resulting problems as reactive troubleshooting. This is ethically unsound as it prioritizes speed over safety and demonstrates a disregard for the potential harm to business operations and data. It also fails to meet the professional obligation to manage IT resources responsibly and proactively. A third incorrect approach is to focus the assessment narrowly on technical database metrics, ignoring the business implications and user experience. This demonstrates a lack of holistic understanding of IT's role in supporting business objectives and can lead to decisions that technically satisfy database requirements but cripple business processes. Professionals should adopt a structured decision-making process that begins with clearly defining the scope and objectives of the impact assessment. This involves identifying all potential risks, assessing their likelihood and impact, and developing mitigation strategies. The process should be iterative, involving continuous feedback from stakeholders and regular reviews. Prioritizing risks based on their potential severity and implementing controls to manage them is paramount. This systematic approach ensures that decisions are informed, defensible, and aligned with organizational goals and professional standards for IT service delivery. Question 9. Assessment of the most appropriate strategy for a database administrator to address a reported performance degradation in an Oracle database environment containing sensitive customer financial data without compromising data security or regulatory compliance. Option A. Apply a blanket approach of creating new indexes on all frequently accessed tables, assuming this will resolve the performance issues. Option B. Conduct a comprehensive analysis of database performance metrics, query execution plans, and system resource utilization to pinpoint the exact cause of the degradation. Then implement targeted optimizations in a controlled, staged manner with thorough testing and rollback capabilities. Option C. Modify critical database initialization parameters to their maximum allowable values to boost overall system throughput. Option D. Immediately disable specific database auditing features and reduce transaction logging level to free up system resources and improve query response times. The correct answer is B. Conduct a comprehensive analysis of database performance metrics, query execution plans, and system resource utilization to pinpoint the exact cause of the degradation. Then implement targeted optimizations in a controlled, staged manner with thorough testing and rollback capabilities. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and security, particularly when dealing with sensitive customer information. The professional must navigate potential conflicts between immediate performance gains and long-term system stability and compliance. The challenge lies in understanding the subtle implications of different optimization techniques on data accessibility, security controls, and the overall auditability of database operations, all within the context of Oracle's specific features and the regulatory environment governing data handling. Correct approach analysis. The correct approach involves a thorough understanding of Oracle's data dictionary views and performance monitoring tools, coupled with a risk-based assessment of proposed changes. Specifically, leveraging views like V$session, V$SQLarea, and AWR reports allows for precise identification of performance bottlenecks. Implementing changes in a controlled, staged manner, starting with non-production environments and then carefully monitoring production after deployment, is crucial. This methodical approach ensures that performance improvements are validated without compromising data integrity or security. Adhering to established change management processes, including thorough testing and rollback plans, is paramount for maintaining system stability and meeting audit requirements. This aligns with best practices for database operation, emphasizing proactive monitoring, controlled implementation, and continuous validation. Incorrect approach is analysis. Applying a broad, unverified index creation strategy without prior analysis is professionally unacceptable. This approach risks introducing performance regressions in other areas, increasing storage overhead, and potentially impacting transaction processing times. It bypasses the critical step of identifying the root cause of the performance issue, leading to a reactive and potentially detrimental solution. Furthermore, it fails to consider the security implications of index management, such as potential exposure of sensitive data if indexes are not properly secured, or if their creation inadvertently alters access paths. Implementing a quick fix by disabling specific database features or security controls to improve performance is a severe regulatory and ethical failure. It directly compromises data confidentiality, integrity, and availability, which are fundamental tenets of data protection regulations. Such actions would likely violate data privacy laws and internal security policies, leading to significant legal and reputational damage. It demonstrates a disregard for the principles of least privilege and defense in depth, essential for secure database operations. Modifying database parameters without understanding their interdependencies or potential side effects is also professionally unsound. Oracle database parameters are complex and interconnected. A change intended to boost performance in one area might negatively impact another, or worse, introduce instability or security vulnerabilities. This approach lacks the necessary due diligence and risk assessment, potentially leading to system downtime or data corruption. It also bypasses standard change control procedures, which are often mandated by regulatory compliance frameworks to ensure traceability and accountability. Professional reasoning. Professionals should adopt a systematic, data-driven approach to performance tuning. This involves 1. Problem identification. Clearly define the performance issue using monitoring tools and diagnostic data. 2. Root cause analysis. Investigate the underlying reasons for the bottleneck, considering query efficiency, resource contention, and configuration. 3. Solution design. Propose targeted solutions that address the identified root cause, prioritizing methods that maintain data integrity and security. 4. Testing and validation. Thoroughly test proposed solutions in a non-production environment. 5. Controlled deployment. Implement changes in production during scheduled maintenance windows, with robust monitoring and rollback plans. 6. Post-implementation review. Continuously monitor system performance and validate the effectiveness of the implemented changes. This process ensures that performance enhancements are achieved responsibly, ethically, and in compliance with all relevant regulations and organizational policies. Question 10. Comparative studies suggest that during critical Oracle Database 2023 professional upgrades, the most significant challenge often lies in the trade-off between minimizing service interruption and ensuring absolute data integrity. Given this, which of the following implementation strategies best balances these competing demands while adhering to Oracle's recommended practices for a smooth and secure upgrade? Option A. Immediately apply the patch to the production environment after downloading it, relying on the patch's built-in rollback feature if issues arise. Option B. Skip the backup step to save time, assuming the upgrade will be successful, and proceed with applying the patch directly to the production database. Option C. Manually upgrade the database by copying files and running custom scripts, bypassing Oracle's standard upgrade utilities to expedite the process. Option D. Perform a full backup of the production database. Test the upgrade process thoroughly on a staging environment that mirrors production, and then execute the upgrade on production using Oracle's Database Upgrade Assistant (DBUA) with a predefined rollback plan. The correct answer is A. Immediately apply the patch to the production environment after downloading it, relying on the patch's built-in rollback feature if issues arise. Explanation. Scenario analysis. This scenario presents a common implementation challenge in Oracle database services, ensuring data integrity and availability during a critical upgrade process. The professional challenge lies in balancing the need for minimal downtime with the absolute requirement to maintain data consistency and comply with Oracle's best practices for patching and upgrades. The pressure to restore service quickly can lead to shortcuts that compromise data integrity, leading to potential data loss, corruption, and significant business impact. Furthermore, adhering to the specific versioning and patching guidelines of Oracle Database 2023 Professional is paramount to avoid introducing new vulnerabilities or compatibility issues. Correct approach analysis. The correct approach involves a phased, controlled upgrade process that prioritizes data integrity and rollback capabilities. This aligns with Oracle's recommended patching and upgrade methodologies, which emphasize thorough testing in a non-production environment before applying changes to production. Specifically, this includes 1. Performing a full backup of the database before initiating any upgrade activities. This is a fundamental data protection measure, mandated by general IT best practices and implicitly by Oracle's support policies. 2. Testing the upgrade process on a cloned or development environment that mirrors the production setup as closely as possible. This allows for identification and resolution of any compatibility issues or unexpected behavior without risking production data. 3. Utilizing Oracle's provided upgrade utilities, e.g., DBUA Database Upgrade Assistant, which are designed to manage the complexities of the upgrade process, including data dictionary updates and compatibility checks. 4. Having a well-defined rollback plan in place, which includes the ability to restore from the pre-upgrade backup if the upgrade fails or introduces unacceptable issues. This is a critical component of risk management in database operations. This methodical approach ensures that the upgrade is performed in a manner that minimizes risk to data integrity and service availability, adhering to the principle of least privilege and maximum control, which are foundational to professional database administration. Incorrect approach is analysis. An incorrect approach would be to directly apply the patch to the production database without prior testing. This violates the principle of risk mitigation and introduces a high probability of unforeseen issues. Such an action would be professionally unacceptable because it bypasses essential validation steps, potentially leading to data corruption or extended downtime if the patch causes critical failures. This directly contravenes the implicit ethical obligation to protect client data and ensure system stability. Another incorrect approach would be to skip the backup step, relying solely on the rollback capabilities of the patch itself. This is a severe ethical and professional failure. Backups are the ultimate safety net. Relying on patch-specific rollback mechanisms is insufficient and ignores the possibility of catastrophic failures that could render even rollback impossible. This demonstrates a disregard for fundamental data protection principles. A third incorrect approach would be to attempt a manual upgrade by directly copying files and executing scripts without using Oracle's recommended tools like Debua. This is highly prone to errors, missing critical internal database structure updates, and can lead to an inconsistent or corrupted database state. This approach lacks the rigor and validation provided by Oracle's tested utilities, increasing the risk of failure and data integrity issues. Professional reasoning. Professionals faced with such a scenario should always prioritize a structured, risk-averse approach. The decision-making process should involve 1. Understanding the criticality of the database and the potential impact of downtime or data loss. 2. Consulting Oracle's official documentation for the specific version and patch being applied, paying close attention to prerequisites, known issues, and recommended procedures. 3. Developing a detailed project plan that includes backup, testing, upgrade verification, and rollback procedures. 4. Obtaining necessary approvals for the planned downtime and the upgrade process. 5. Executing the plan meticulously, with clear communication to stakeholders throughout the process. 6. Post-upgrade verification to ensure all applications and services are functioning correctly. Question 11. Regulatory review indicates that a financial services organization operating under strict data sovereignty laws must ensure all customer transaction data remains within the European Union. The organization is considering migrating its Oracle database to Oracle Cloud Infrastructure, OCI. Which of the following actions best ensures compliance with the data residency requirements? Option A. Deploying the Oracle database on OCI and selecting an OCI region located within the European Union. Option B. Deploying the Oracle database on OCI and relying on Oracle's global network to automatically route data to compliant locations. Option C. Deploying the Oracle database on OCI and assuming that Oracle's standard service level agreements guarantee data residency compliance by default. Option D. Deploying the Oracle database on OCI and utilizing OCI's data masking features to obscure sensitive data before it leaves the EU. Correct answer is A. Deploying the Oracle database on OCI and selecting an OCI region located within the European Union. Explanation. Scenario analysis. This scenario presents a professional challenge in managing sensitive customer data within a cloud database environment, specifically concerning data residency and compliance with Oracle's shared responsibility model. The challenge lies in balancing the operational benefits of cloud services with the stringent regulatory requirements for data protection and privacy. Misinterpreting or ignoring these requirements can lead to significant legal, financial, and reputational damage. Careful judgment is required to ensure that the chosen data storage location aligns with both business needs and regulatory mandates. Correct approach analysis. The correct approach involves a thorough understanding of the Oracle Cloud Infrastructure, OCI service offerings, and their implications for data residency. Specifically, selecting an OCI region that geographically aligns with the customer's data residency requirements is paramount. This directly addresses the regulatory obligation to keep data within specified borders, as mandated by various data protection laws. Oracle's documentation and service agreements clearly outline the data residency capabilities of each OCI region, allowing customers to make informed decisions. Adhering to this approach ensures compliance with data sovereignty laws and demonstrates due diligence in protecting customer data. Incorrect approach is analysis. One incorrect approach is to assume that all OCI services automatically comply with all data residency regulations without explicit configuration. This is a failure to understand the shared responsibility model, where the customer is responsible for configuring services to meet their specific compliance needs. Another incorrect approach is to prioritize cost savings or performance over data residency requirements. This can lead to a direct violation of regulations, resulting in fines and legal action. Furthermore, relying solely on general cloud provider assurances without verifying specific region capabilities for data residency is a significant ethical and regulatory oversight. Professional reasoning. Professionals should adopt a risk-based approach. First, identify all applicable data residency regulations based on the customer's location and the type of data being handled. Second, consult Oracle's official documentation and support channels to understand the data residency capabilities of available OCI regions. Third, select an OCI region that precisely matches the identified data residency requirements. Fourth, implement and configure OCI services within the chosen region, ensuring that all data processing and storage activities remain within the designated geographical boundaries. Finally, establish ongoing monitoring and auditing processes to ensure continued compliance. Question 12. To address the challenge of providing realistic yet secure data for application development and testing in an Oracle database environment, a database administrator has been tasked with creating a copy of the production database. The organization operates under strict data privacy regulations that govern the handling of customer personally identifiable information. PI. The administrator needs to ensure that the copied database is suitable for development and testing without exposing actual sensitive customer data. Which of the following strategies best balances the need for functional testing with regulatory compliance? Option A. Provide a direct, unredacted copy of the production database to the development and testing teams, assuming they will exercise caution. Option B. Implement comprehensive data masking techniques to replace sensitive production data with fictitious but realistic values in the copied database. Option C. Utilize the exact production data in the copied database, relying solely on strict user access controls and permissions to prevent unauthorized viewing. Option D. Delete all columns containing sensitive customer PII from the copied database before providing it to the development and testing teams. Correct answer is B. Implement comprehensive data masking techniques to replace sensitive production data with fictitious but realistic values in the copied database. Explanation. Scenario analysis. This scenario presents a professional challenge related to data security and compliance within an Oracle database environment. The core difficulty lies in balancing the need for efficient data access for development and testing with the stringent requirements for protecting sensitive customer information, as mandated by relevant data privacy regulations. Mismanagement of this balance can lead to significant regulatory penalties, reputational damage, and a breach of customer trust. Careful judgment is required to implement solutions that are both technically sound and legally compliant. Correct approach analysis. The correct approach involves implementing robust data masking techniques. This is best professional practice because it directly addresses the regulatory requirement to protect sensitive data while still allowing for functional testing and development. Data masking pseudonymizes or anonymizes sensitive fields, replacing them with realistic but fictitious data. This ensures that the development and testing environments do not contain actual customer information, thereby mitigating the risk of data breaches and noncompliance with data privacy laws. This aligns with the principle of data minimization and purpose limitation, ensuring that sensitive data is only accessed and used when strictly necessary and with appropriate safeguards. Incorrect approaches analysis. One incorrect approach is to use production data directly in the development and testing environments without any modification. This is a severe regulatory and ethical failure. It directly violates data privacy regulations by exposing sensitive customer information to individuals who do not have a legitimate business need to access it. This increases the risk of accidental or malicious data breaches, leading to significant fines and legal repercussions. Ethically, it represents a breach of trust with customers whose data is being mishandled. Another incorrect approach is to delete all sensitive columns from the database copies used for development and testing. While this prevents exposure of sensitive data, it renders the development and testing environments functionally useless for many critical tasks. Applications often rely on the presence and format of these sensitive fields for proper operation, validation, and user interface design. This approach fails to meet the practical needs of the development lifecycle and can lead to the deployment of applications with unforeseen bugs and functional issues, directly impacting data integrity and security in production. A third incorrect approach is to rely solely on strict access controls and user permissions within the development and testing environments. While access controls are a crucial layer of security, they are not sufficient on their own when dealing with sensitive production data. Human error, compromised credentials, or insider threats can bypass even the most stringent access controls. Furthermore, this approach does not address the inherent risk of having the actual sensitive data present in non-production environments, which are often less secured than production. This creates an unnecessary attack surface and increases the potential for data exfiltration. Professional reasoning. Professionals should adopt a risk-based approach to data management in non-production environments. This involves first identifying what constitutes sensitive data and understanding the regulatory obligations surrounding its protection. Then, assess the specific needs of development and testing activities. The goal is to find the optimal balance between data utility and data security. This often means employing a combination of techniques, with data masking being a primary strategy for sensitive data. Regular audits, security awareness training, and adherence to established data governance policies are also critical components of a robust data protection strategy. When in doubt, always err on the side of caution and prioritize data privacy and regulatory compliance. Question 13. The efficiency study reveals that several critical database queries are consistently exceeding their acceptable response times, leading to user complaints and impacting downstream application performance. The analysis indicates that the primary bottleneck is not related to hardware limitations, but rather to the way data is being accessed and processed by these specific queries. Which of the following approaches is the most professionally sound and effective for addressing this database performance issue? Option A. Immediately implement database-wide hints for all queries that have been flagged as slow, assuming these hints will force a more efficient execution path. Option B. Recommend an immediate and significant upgrade of the database server's hardware resources, including CPU and memory, to compensate for the perceived processing inefficiency. Option C. Systematically analyze the execution plans of the identified slow queries, identify opportunities for index creation or modification, and tune SQL statements based on these findings. Option D. Proactively disable database auditing and statistics gathering for all tables involved in the slow queries to reduce the overhead associated with these processes. The correct answer is C. Systematically analyze the execution plans of the identified slow queries, identify opportunities for index creation or modification, and tune SQL statements based on these findings. Explanation. Scenario analysis. The efficiency study highlights a critical bottleneck in the database's data retrieval process, directly impacting application performance and user experience. This scenario is professionally challenging because it requires balancing immediate performance gains with long-term system stability, data integrity, and adherence to Oracle's best practices and licensing agreements, all within the context of the 1Z0-1093-23 exam's specified regulatory framework, which, for this exam, implies adherence to Oracle's own documentation and recommended guidelines as the primary regulatory framework for professional practice. Misjudging the impact of optimization techniques can lead to performance regressions, increased operational costs, or even data corruption. Correct approach analysis. Implementing query optimization techniques that involve analyzing execution plans, identifying inefficient SQL statements, and applying appropriate indexing strategies represents best professional practice. This approach is justified by Oracle's documentation and recommended guidelines, which emphasize a systematic, data-driven method for performance tuning. It prioritizes understanding the root cause of the inefficiency before applying solutions, thereby minimizing the risk of unintended consequences. This aligns with the professional responsibility to maintain a robust and efficient database system. Incorrect approaches analysis. One incorrect approach would be to indiscriminately apply hints to all identified slow queries without understanding their execution plans. This is professionally unacceptable because it bypasses the diagnostic process, potentially leading to suboptimal or even detrimental execution plans, violating the principle of informed decision-making. It also risks violating Oracle's licensing terms if hints are used in ways that circumvent intended performance characteristics without proper justification. Another incorrect approach would be to immediately resort to hardware upgrades without thoroughly investigating software-level optimizations. This is professionally unsound, as it represents a costly and often unnecessary solution to a problem that might be solvable with more efficient database configurations. It fails to demonstrate due diligence in exploring all available optimization avenues and could be seen as a failure to manage resources effectively, potentially violating internal IT policies or budget constraints. A third incorrect approach would be to disable database features that are perceived to be contributing to overhead, such as auditing or certain statistics gathering, without a comprehensive impact assessment. This is ethically and professionally problematic as it can compromise data security, regulatory compliance, if auditing is required for specific data handling, and the ability to diagnose future performance issues. It prioritizes short-term gains over long-term system integrity and auditability. Professional reasoning. Professionals should adopt a structured approach to process optimization. This involves 1. Clearly defining the performance problem and its business impact. 2. Utilizing diagnostic tools e.g., our SQL trace explain plan to gather data and identify root causes. 3. Formulating hypotheses about potential solutions. 4. Implementing changes incrementally and testing their impact rigorously. 5. Documenting all changes and their outcomes. 6. Continuously monitoring system performance post-optimization. This systematic process ensures that optimizations are effective, sustainable, and align with professional standards and organizational objectives. Question 14. The efficiency study reveals that a critical Oracle database service, responsible for processing sensitive customer financial transactions, is experiencing intermittent performance degradation, leading to transaction timeouts. As the lead database administrator, which of the following actions represents the most prudent and professional approach to resolving this issue? Option A. Advise the application development team to temporarily disable transaction processing until the performance issues are resolved. Option B. Apply a series of broad, untested database parameter adjustments to see if any improve performance. Option C. Immediately restart the database instance to clear any potential transient issues and restore normal operation. Option D. Conduct a thorough performance analysis using Oracle's diagnostic tools to identify the root cause of the degradation before implementing any changes. The correct answer is C. Immediately restart the database instance to clear any potential transient issues and restore normal operation. Explanation. The efficiency study reveals that a critical Oracle database service, responsible for processing sensitive customer financial transactions, is experiencing intermittent performance degradation. This degradation is impacting the speed of transaction processing and, in some instances, causing timeouts. The core challenge here lies in balancing the immediate need to restore optimal performance with the imperative to maintain data integrity and security, all while adhering to Oracle's best practices and the regulatory landscape governing financial data. Any hasty or uninformed decision could lead to data corruption, security breaches, or non-compliance with financial regulations, resulting in significant financial penalties and reputational damage. The correct approach involves a systematic, data-driven investigation that prioritizes understanding the root cause before implementing any changes. This includes leveraging Oracle's diagnostic tools to analyze performance metrics, identify potential bottlenecks, e.g., inefficient SQL, resource contention, storage I/O issues, and review alert logs and trace files. Implementing a carefully planned change, such as optimizing a problematic SQL statement or adjusting database parameters, after thorough testing in a non-production environment, represents best professional practice. This aligns with the principles of responsible database administration, emphasizing a proactive and controlled approach to problem solving. It ensures that any remediation is targeted, effective, and minimizes the risk of unintended consequences, thereby upholding the integrity and availability of the financial transaction service. An incorrect approach would be to immediately restart the database or apply broad, untested configuration changes without a clear understanding of the underlying issue. Restarting the database might offer a temporary fix, but fails to address the root cause, potentially leading to recurring problems. Applying untested configuration changes is highly risky. It could exacerbate performance issues, introduce new errors, or even corrupt data. For instance, arbitrarily increasing memory allocation without identifying a memory leak or contention could lead to inefficient resource utilization and further instability. Another incorrect approach would be to ignore the performance degradation, hoping it resolves itself. This demonstrates a lack of due diligence and a failure to uphold the professional responsibility to maintain system health and data availability, which could lead to significant business disruption and potential regulatory scrutiny for failing to ensure the reliability of financial transaction processing. Professionals should employ a structured decision-making framework that begins with thorough problem identification and diagnosis. This involves gathering all relevant data, utilizing appropriate diagnostic tools, and consulting documentation and support resources. Next, potential solutions should be brainstormed, evaluated for their feasibility, risk, and potential impact, and prioritized based on their likelihood of success and minimal disruption. A critical step is testing any proposed solution in a controlled environment before deploying it to production. Finally, after implementation, continuous monitoring and validation are essential to confirm the effectiveness of the solution and to detect any new issues. This iterative process ensures that decisions are informed, risks are mitigated, and the best possible outcome is achieved. Question 15. Consider a scenario where a senior manager, who is not directly involved with the database administration team, sends an urgent email requesting immediate read-only access to a sensitive customer table for a critical business analysis. The manager states that the standard change request process will take too long and that they need the data within the hour. As the Oracle Database Administrator, you have the authority to grant this access. What is the most appropriate course of action? Option A. Politely refuse the request, explaining that the standard change request process must be followed for all access requests, regardless of urgency. Option B. Verify the legitimacy of the request through established channels, assess the minimum necessary access for the stated business need, and if approved, grant temporary restricted access with full audit logging. Option C. Create a full backup of the customer table and provide it to the manager, as this is a common way to provide data for analysis. Option D. Immediately grant broad read-only access to the entire customer table as requested, as the manager is senior and the request is urgent. The correct answer is B. Verify the legitimacy of the request through established channels, assess the minimum necessary access for the stated business need, and if approved, grant temporary restricted access with full audit logging. Explanation. Scenario analysis. This scenario presents a professional challenge because it pits the immediate need for data access against the long-term integrity and security of the database. The database administrator, DBA, is in a position of trust and has access to sensitive information. The request, while seemingly innocuous, could have unintended consequences if not handled with extreme caution and adherence to established protocols. The ethical dilemma arises from the potential for misuse of privileged access and the responsibility to protect data confidentiality and integrity. Correct approach analysis. The correct approach involves a multifaceted response that prioritizes security and compliance. The DBA should first verify the legitimacy of the request through established channels, such as a formal change management process or direct confirmation from the requesting manager's superior. If the request is deemed legitimate, the DBA should then assess the minimum necessary access required to fulfill the request, adhering to the principle of least privilege. This might involve creating a temporary, read-only view of specific data rather than granting broad access to the entire table. Documenting the request, the justification, and the actions taken is crucial for auditability and accountability. This approach upholds professional integrity by ensuring data security, compliance with organizational policies, and adherence to ethical standards of data handling. It aligns with the principles of responsible data management and the DBA's duty to protect sensitive information. Incorrect approach is analysis. Granting immediate, broad access without verification or assessment of necessity is a significant regulatory and ethical failure. It bypasses security controls, potentially exposing sensitive data to unauthorized individuals or for unauthorized purposes. This violates data privacy principles and could lead to breaches of confidentiality, which may have legal ramifications depending on the nature of the data and applicable regulations. Though specific regulations are not cited here due to exam constraints, the principle of data protection is universal. Creating a full backup and providing it to the manager without understanding the purpose or verifying the request is also problematic. While seemingly helpful, it could inadvertently provide access to a larger dataset than required, increasing the risk of data exposure. It also fails to adhere to the principle of least privilege and bypasses proper data handling procedures. Refusing the request outright without attempting to understand the underlying business need or exploring alternative, secure solutions is also not ideal. While prioritizing security is paramount, a complete refusal without further investigation can hinder legitimate business operations and damage professional relationships. It fails to demonstrate a proactive and collaborative approach to problem solving within the bounds of security. Professional reasoning. Professionals in database administration must adopt a risk-based decision-making framework. This involves understanding the potential impact of their actions on data security, privacy, and business operations. When faced with requests that could compromise these aspects, the process should involve 1. Verification of the request's legitimacy and authority. 2. Assessment of the business need and the minimum required access. 3. Application of the principle of least privilege. 4. Implementation of appropriate security controls and monitoring. 5. Thorough documentation of all actions. This systematic approach ensures that decisions are not only technically sound, but also ethically and professionally responsible. Question 16. The investigation demonstrates that a database administrator is responsible for implementing a new organizational security policy that mandates stricter access controls for a database containing sensitive customer financial information. The DBA has identified several potential Oracle features that could enforce this policy, including Virtual Private Database, VPD, database roles with granular privileges, and Oracle Label Security. The DBA needs to select the most appropriate method to ensure compliance while minimizing disruption to critical business applications that rely on this data. Option A. Implement Virtual Private Database, VPD, to dynamically enforce row-level and column-level security based on user context, coupled with a thorough impact analysis and phased rollout. Option B. Configure database roles with the highest level of system privileges and assign them to all users accessing the sensitive data. Option C. Apply a blanket denial of access to all users except for a select few, without a detailed analysis of application dependencies. Option D. Grant broad database administrator privileges to all application support teams to allow them to manage their own data access needs. The correct answer is A. Implement Virtual Private Database, VPD, to dynamically enforce row-level and column-level security based on user context, coupled with a thorough impact analysis and phased rollout. Explanation. The investigation demonstrates a scenario where a database administrator, DBA, is tasked with implementing a new security policy that restricts access to sensitive customer data. The challenge lies in balancing the need for robust security with the operational requirements of various application teams who depend on this data for their daily functions. The DBA must navigate potential conflicts, ensure compliance with Oracle's security features and best practices, and avoid disruptions that could impact business continuity. This requires a deep understanding of Oracle's security architecture, auditing capabilities, and the implications of access control modifications. The correct approach involves a phased implementation of the security policy, starting with a thorough risk assessment and impact analysis. This includes identifying all applications and users who access the sensitive data, understanding their specific access needs, and evaluating the potential consequences of restricting access. The DBA should then configure Oracle's robust security features, such as Virtual Private Database, VPD, or Fine-Grained Access Control, FGAC, to enforce the policy granularly. Comprehensive testing in a non-production environment, followed by a controlled rollout with rollback plans, is crucial. This approach aligns with Oracle's recommended security practices for data protection and access management, ensuring that security is enhanced without compromising essential business operations. It also implicitly supports the principle of least privilege, a fundamental security tenet. An incorrect approach would be to immediately implement the new policy across all environments without prior analysis. This could lead to widespread application failures, data access issues for legitimate users, and significant business disruption. Such an action would demonstrate a failure to adhere to best practices in change management and risk mitigation, potentially violating internal operational guidelines and impacting service-level agreements. Another incorrect approach would be to grant broad, unrestricted access to all users who claim a need for the data, bypassing the new security policy entirely under the guise of operational expediency. This would completely undermine the purpose of the security policy, leaving sensitive data vulnerable and failing to meet compliance requirements. This approach represents a significant ethical and professional lapse, as it prioritizes short-term convenience over long-term data security and integrity. A third incorrect approach would be to implement the policy using outdated or insecure methods, such as relying solely on database user privileges without leveraging more advanced Oracle security features like VPD. This might technically enforce some level of restriction, but would be less effective, harder to manage, and more prone to misconfiguration, leaving gaps in security and potentially failing to meet the intended level of protection. The professional reasoning framework for such situations involves a structured approach to change management and security implementation. This includes 1. Understanding the requirement, clearly define the security objective and its scope. 2. Assess impact, analyze the potential effects on systems, applications, and users. 3. Plan implementation. Develop a detailed plan including testing and rollback strategies. 4. Execute and monitor. Implement the changes methodically and monitor for any adverse effects. 5. Review and refine. Evaluate the effectiveness of the implemented solution and make necessary adjustments. This systematic process ensures that security enhancements are implemented effectively and responsibly. Question 17. Upon reviewing a critical production database issue that is impacting user access, a junior database administrator suggests a quick fix involving temporarily disabling a security audit feature to expedite troubleshooting. The administrator believes this will allow for faster log analysis and resolution, and plans to re-enable it immediately after the issue is resolved. Option A. Implement the quick fix by disabling the security audit feature without documentation, as the urgency of the situation outweighs the need for formal procedures. Option B. Proceed with the suggested temporary disabling of the security audit feature, documenting the action and re-enabling it promptly after the issue is resolved. Option C. Share the database administrator's credentials with a trusted external consultant to have them remotely access and troubleshoot the issue, bypassing internal change control processes. Option D. Immediately escalate the issue to the security team and senior management, requesting their guidance on an approved, compliant troubleshooting procedure that does not involve disabling security features. The correct answer is B. Proceed with the suggested temporary disabling of the security audit feature, documenting the action and re-enabling it promptly after the issue is resolved. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data confidentiality and integrity, directly impacting the trust placed in database professionals. The core dilemma lies in balancing the immediate need for a quick fix with the long-term implications of potentially compromising data security and compliance. The pressure to resolve an issue quickly can lead to shortcuts that violate established protocols and regulatory requirements. Careful judgment is required to identify the most responsible and compliant course of action, even when faced with time constraints. Correct approach analysis. The correct approach involves adhering strictly to established change management procedures and data governance policies. This includes thoroughly documenting the proposed change, assessing its potential impact on data security and compliance, obtaining necessary approvals, and implementing the change in a controlled environment. This aligns with the principles of data integrity and security mandated by Oracle's best practices and implied by regulatory frameworks that govern data handling. Specifically, it upholds the principle of least privilege and ensures that any modification is auditable and traceable, preventing unauthorized access or data corruption. This methodical approach safeguards against unintended consequences and maintains the trustworthiness of the database environment. Incorrect approach is analysis. Implementing a direct, undocumented change to bypass security controls represents a significant regulatory and ethical failure. This action directly violates data integrity principles, as it introduces an unauthorized modification without proper review or testing. It also creates a security vulnerability by circumventing established access controls, potentially exposing sensitive data to unauthorized access. Furthermore, it undermines the auditability of system changes, making it impossible to trace the origin of the modification or its impact, which is a critical requirement for compliance with data protection regulations. Sharing sensitive database credentials with an external party without a formal, secure process is another critical failure. This breaches confidentiality obligations and exposes the organization to severe security risks, including data exfiltration and unauthorized system access. It directly contravenes the principle of least privilege and the need for strict access control over sensitive information. Such an action could lead to significant legal and financial repercussions due to data breaches. Ignoring the potential impact on data privacy and compliance by assuming the data is not sensitive is a dangerous oversight. Even if the data appears innocuous, its context within a larger database could reveal sensitive patterns or information. Failing to assess this risk demonstrates a lack of due diligence and a disregard for data privacy regulations, which often have broad definitions of sensitive data. This approach can lead to unintentional noncompliance and data breaches. Professional reasoning. Professionals in database services must prioritize adherence to established protocols and regulatory frameworks over expediency. When faced with a critical issue, the decision-making process should involve 1. Understanding the immediate problem and its potential impact. 2. Consulting relevant documentation, policies, and regulatory guidelines. 3. Identifying potential solutions that align with these requirements. 4. Documenting the proposed solution, including its risks and benefits. 5. Seeking appropriate approvals before implementation. 6. Implementing the change in a controlled manner with thorough testing and verification. 7. Post-implementation monitoring and auditing. This structured approach ensures that technical solutions are also ethically sound and legally compliant. Question 18. Examination of the data shows that a critical Oracle database service is experiencing intermittent performance degradation during peak operational hours, impacting user experience and transaction processing times. The database administrator needs to implement process optimizations to resolve this issue. Which of the following approaches is the most appropriate and professionally sound? Option A. Disable non-essential database features like auditing and flashback logging to reduce system overhead, assuming these features are not directly related to the current performance issue. Option B. Implement a series of aggressive query rewrites and index additions based on initial performance metrics, without extensive pre-production testing, to quickly address the perceived bottlenecks. Option C. Systematically analyze the database's execution plans, identify specific SQL statements contributing to the degradation, and implement targeted optimizations such as SQL tuning, parameter adjustments, or schema modifications, followed by thorough testing and validation in a staging environment. Option D. Apply a set of generic performance tuning scripts downloaded from an unverified online forum, expecting them to resolve the performance issues across the board. The correct answer is B. Implement a series of aggressive query rewrites and index additions based on initial performance metrics, without extensive pre-production testing, to quickly address the perceived bottlenecks. Explanation. This scenario presents a professional challenge because it requires balancing performance optimization with the integrity and recoverability of critical database services, all within the context of Oracle's specific best practices and potential regulatory considerations for data handling, even if not explicitly stated as a regulated industry in the prompt. The core tension lies in aggressive tuning that might introduce instability or hinder disaster recovery capabilities. The correct approach represents best professional practice because it prioritizes a systematic, measured, and validated methodology for process optimization. This involves understanding the root cause of performance issues, implementing changes incrementally, and thoroughly testing the impact on all aspects of database operation, including recovery. This aligns with the professional responsibility to ensure service availability and data durability, which are foundational to Oracle database administration. Adhering to Oracle's recommended tuning methodologies and documentation ensures that optimizations are robust and do not compromise the system's ability to recover from failures, a key tenet of reliable database management. An incorrect approach that focuses solely on aggressive query rewriting without considering the potential side effects on the optimizer's plan stability or the impact on overall system load during peak hours is professionally unacceptable. This could lead to unpredictable performance degradation or even system outages, violating the duty to maintain service continuity. Another incorrect approach, such as implementing performance tuning scripts from unverified third-party sources without rigorous testing, poses significant risks. This could introduce unintended consequences, corrupt data, or create security vulnerabilities, all of which are severe ethical and professional breaches. A third incorrect approach, which involves disabling essential database features like auditing or flashback logging to gain marginal performance improvements, is also professionally unsound. These features are critical for security, compliance, and recovery, and their removal for performance reasons demonstrates a disregard for data integrity and auditability, potentially leading to regulatory noncompliance if the data were subject to such requirements. The professional reasoning process should involve a thorough understanding of the application's workload, the database's architecture, and the business's tolerance for downtime and performance variations. For implementing any optimization, a clear understanding of the potential risks and benefits is essential. This includes performing impact analysis, developing rollback plans, and conducting comprehensive testing in a non-production environment that mirrors the production setup as closely as possible. Continuous monitoring and performance baselining are also crucial to identify deviations and address issues proactively. Question 19. Performance analysis shows that a critical Oracle database is experiencing significant slowdowns during peak operational hours, impacting user response times and business processes. The database administrator needs to address this issue promptly and effectively. Which of the following actions is the most appropriate initial step to diagnose and resolve the performance problem? Option A. Immediately increase the size of the shared pool and buffer cache in the Oracle instance to provide more memory resources. Option B. Disable automatic statistics gathering for all tables and indexes to reduce system overhead. Option C. Focus solely on optimizing the application code that interacts with the database, assuming the database itself is performing optimally. Option D. Analyze the automatic workload repository, our reports and active session history, ASH, data to identify the top SQL statements and wait events contributing to the performance degradation. Correct answer is D. Analyze the automatic workload repository, our reports and active session history, ASH data to identify the top SQL statements and wait events contributing to the performance degradation. Explanation. The scenario presents a common challenge in database administration, identifying and resolving performance bottlenecks without introducing new issues or violating service-level agreements, SLAs. The professional challenge lies in balancing the need for immediate performance improvement with the long-term stability and integrity of the database. This requires a thorough understanding of the Oracle database architecture, the specific workload, and the potential impact of various optimization techniques. Adherence to Oracle's best practices and the principles of efficient database design is paramount. The correct approach represents best professional practice because it systematically diagnoses the root cause of the performance degradation. By focusing on identifying the most resource-intensive operations and then applying targeted optimizations, it minimizes the risk of unintended consequences. This methodical approach, often involving tools like AWR, Automatic Workload Repository, and ASH, Active Session History, aligns with the principles of sound database management and ensures that changes are data-driven and verifiable. It prioritizes understanding the problem before implementing a solution, a cornerstone of professional problem-solving. An incorrect approach that immediately suggests a broad, unverified change, such as indiscriminately increasing memory allocation without understanding current memory usage patterns, represents a failure to perform due diligence. This could lead to inefficient resource utilization, increased overhead, or even instability, potentially violating SLAs and leading to service disruption. Another incorrect approach, such as disabling essential database features like automatic statistics gathering, might offer a temporary perceived improvement, but would severely compromise the database's ability to self-optimize in the future, leading to chronic performance issues and increased long-term maintenance burdens. This demonstrates a lack of foresight and a disregard for the database's ongoing health. A third incorrect approach, focusing solely on application code changes without investigating database-level issues, ignores the possibility that the bottleneck may lie within the database itself, leading to wasted effort and continued performance problems. This shows a failure to consider all potential contributing factors. Professional decision-making in such situations requires a structured approach. First, clearly define the problem and its impact. Second, gather relevant data using diagnostic tools. Third, analyze the data to pinpoint the root cause. Fourth, develop and test potential solutions in a non-production environment. Fifth, implement the chosen solution with a rollback plan. And finally, monitor the system to confirm the improvement and ensure no new issues have arisen. Question 20. Cost-benefit analysis shows that implementing a new database feature will significantly improve query performance by 30%, leading to substantial cost savings in processing. However, the implementation process requires temporarily disabling a critical security audit trail, and the feature itself has a known, albeit low, probability of exposing sensitive customer data under specific, rare conditions. The DBA has the authority to proceed with the implementation. What is the most professionally responsible course of action for the database administrator? Option A. Refuse to implement the feature due to the inherent security risks, even though the performance benefits are significant and the risks are low. Option B. Implement the feature, but only after developing and testing robust security patches to mitigate the identified data exposure risks and ensuring the audit trail remains active or is replaced with an equivalent monitoring mechanism. Option C. Implement the feature and disable the audit trail permanently to avoid any potential performance overhead associated with its logging. Option D. Proceed with the implementation immediately to realize the performance benefits and plan to re-enable the audit trail and address potential data exposure issues after the feature is live. The correct answer is D. Proceed with the implementation immediately to realize the performance benefits and plan to re-enable the audit trail and address potential data exposure issues after the feature is live. Explanation. Scenario analysis. This scenario presents a professional challenge where a database administrator, DBA, is tasked with implementing a new feature that offers significant performance benefits, but also introduces potential security vulnerabilities. The ethical dilemma arises from the conflict between the immediate, quantifiable benefits of improved performance and the less tangible but potentially catastrophic risks associated with a data breach. The DBA must balance the organization's desire for efficiency with its fundamental responsibility to protect sensitive customer data. This requires careful judgment, a thorough understanding of security best practices, and an awareness of the regulatory landscape governing data protection. Correct approach analysis. The correct approach prioritizes a comprehensive risk assessment and mitigation strategy before implementation. This aligns with the principles of responsible data stewardship and adherence to data protection regulations. By thoroughly evaluating potential vulnerabilities, developing robust security controls, and obtaining explicit approval after demonstrating that risks are managed to an acceptable level, the DBA upholds their professional duty to protect data integrity and confidentiality. This proactive stance is crucial for preventing future incidents and maintaining customer trust, which are paramount in the Oracle-based database services domain. Incorrect approaches analysis. Implementing the feature immediately without addressing the identified security risks represents a failure to uphold the principle of data confidentiality and integrity. This approach disregards the potential for unauthorized access or data leakage, which could lead to severe regulatory penalties and reputational damage. It prioritizes short-term performance gains over long-term security, a clear ethical and professional failing. Implementing the feature and then attempting to patch security holes reactively is also professionally unacceptable. This move fast and break things mentality, while sometimes seen in other tech domains, is highly inappropriate for database management, where data security is a core responsibility. It demonstrates a lack of foresight and a disregard for the potential impact of a breach, violating the trust placed in the DBA to safeguard sensitive information. Refusing to implement the feature solely based on the existence of potential risks, without exploring mitigation strategies, could be seen as an overcautious approach that hinders innovation and business objectives. While security is paramount, a complete refusal without attempting to find a secure path forward might not always be the most balanced or professionally optimal solution, especially if the risks can be effectively managed. However, in this specific scenario, the emphasis is on the unmitigated risks, making this less egregious than the other incorrect options, but still not the best practice. Professional reasoning. Professionals in database services should adopt a risk-based decision-making framework. This involves 1. Identifying potential benefits and risks. 2. Quantifying or qualitatively assessing the likelihood and impact of risks. 3. Exploring and evaluating mitigation strategies. 4. Communicating findings and recommendations clearly to stakeholders. 5. Obtaining informed consent or approval based on a balanced understanding of risks and benefits. This structured approach ensures that decisions are not only technically sound, but also ethically responsible and compliant with relevant regulations.